Hello and welcome. This is going to be another Chapter 9 video on how to solve quadratic equations. Today we're going to bring back an old friend called factoring. Now at the time when we were factoring, I didn't really give us a good motivation for why we were doing it other than your math teacher asked you to do so and you went along with the process. But it turns out that factoring is actually a technique which we can use to solve problems with powers greater than 1. And since quadratics have a highest power of 2, what we're going to be doing is using factoring as a way to break down a problem with the second power into two mini problems with the first power, which we did in semester 1. Now you can think about these techniques can be extended to even higher powers, 3, 4, 5, and the general principle behind what we're doing is going to remain the same even though some of the small details might change up a little bit. So let's get refreshed on factoring and use it in the context of solving some quadratic equations. Now right here at the top we've got two lovely trinomials to factor. We have x squared plus 7x plus 10 and 5x squared plus 20x plus 15. Now when we were going over the factoring unit, I made a big deal out of looking at the x squared term and that being a clue for what your first step might be. We'll go through the standard factoring of a trinomial, which is you look at the last term, which is always the product. So 10 could have come from 1 times 10, or it could have come from 2 times 5. And the middle term in our trinomial, the one with just a single x, came from the sum of these two factors. While 1 and 10 will add up to 11, 2 plus 5 will actually add up to 7. So our two factored binomials would be x plus 2 and x plus 5. Now if you wanted to go back and check yourself, you could redistribute this set of two binomials and you would in fact get what we have up at the top. Now when we go and we factor trinomials when our leading term, our x squared, is not 1, that opens us up to a lot of options about how we could start it. The best way to do it is to always look for a GCF because that's going to keep the problem as small as possible. It's going to reduce what we need to pay attention to. And I noticed that yes, all of those coefficients are in fact divisible by 5. So what I would do is I would factor out this GCF, x squared plus 4x plus 3. And what we arrive at again is a similar trinomial to what we worked on in problem A, where our leading coefficient is 1, so that means we can look at some of the factors of 3, which are 1 and 3, and lo and behold, 1 and 3 add up to 4. So that's telling me that our two factors could be x plus 3 and x plus 1. You'll notice that I wrote these out of order from the last set of numbers that I did. And that's because I want you to, I wanted to bring up the point of emphasis that it doesn't matter which factor comes first, but if you're dealing with positives or negatives, it does actually matter which number the negative goes with. Does it go with the 3? Does it go with the 1? But in this case, we didn't have to worry about that whatsoever. So let's take a look. Solving by factoring right here. It says when you factor a quadratic, you are breaking it down into two, and you would say, looks like the pen's off the page. There it is. You would be breaking down into two smaller linear equations. And by linear equations, that is also represented as the highest power being 1. So something like 2x plus 5 or as simple as x plus 3 like we had above. Along with, and this is a good vocab word, the zero product property, you can solve for x individually. So while factoring is a technique that we've used before in the past to break apart higher powers, it's actually the follow-up step, the zero product property, which is going to enable us to solve for x. I'll give you a little preview of that. Let's say I've already factored a problem, and I am making up these numbers on the spot. X plus 2 and x minus 10. Now in the problems that we're going to do, as you look below, they are equal to 0. And what that means is when you plug in an x here, you're going to have to add 2 and minus 10, and once you figure out what those numbers are, you multiply them and you see if you get 0. But obviously, any old random number isn't quite going to work out. Like, let's say I picked 20. Well, if I picked 20, that would be 22 times 10, which is most certainly not going to be 0. So that isn't going to be our magic number that we wanted. Now, the zero product property says that the only way to multiply to 0, word product, so the only way to multiply by 0 is if you have a 0. In other words, something like 4 times 0 will give you 0, or 0 times 10 will also give you 0. So this is a seemingly unhelpful fact, but when we start using it in the context of an equation, it actually turns out to be incredibly powerful. So let's take a look at this. I could imagine, what if x plus 2 is equal to 0? Well, the only number x that would make that work would be negative 2. Similarly here, x minus 10 could be 0, and the only number to make that work would be if x were 10. So the solution to this already factored equation would be both negative 2 and positive 10, because by plugging them in, the first time I would get 0 times, not 10, 0 times negative 12, which would be 0. And if I plugged in 10, I would get 12 times 0, which is also 0. So there you have it. That's the zero product property in action. It allows us to take each separate factor and solve them separately. Now let's go ahead and let's apply the factoring technique and the zero product property in the context of these problems. So we're going to start off with factoring once again, and I'm looking at the factors of negative 12. So they would be 1 and 12, 2 and 6, 3 and 4. Now one of these numbers has to be negative, otherwise we couldn't multiply to a negative 12. So if I think about it, if I did negative 1 plus 12, that would be 11. Okay, that's getting too big. If this were negative 6 minus 2 is 4, well, it's close because I want a negative 4. So it would actually be a negative 6. So if I do x minus 6 times x plus 2, that would give me the trinomial I have above. It would all check out. And now the zero product property is telling me, alright, if x minus 6 is 0, that means that x should be 6. And we actually just did this one a moment ago. That would mean that x has to be minus 2. So there we go. We factored it. We looked at each individual factor and used the zero product property. Here, it looks like we have a GCF that we can factor out. So the GCF would be 3. Let's just have that chilling out in front. X squared plus 8x plus 15. Well, 15 doesn't have that many factors. It's got 1 and 15. That's not going to make it 8. 3 times a 5, those will certainly add up to 8. So x plus 3, x plus 5 equals 0. And that 3 is staying again out in front. So if I were to think to myself, if x plus 3 were equal to 0, that would mean that the inverse, right, so negative 3 would have to be the one that makes that work. And similarly here, if x plus 5 were equal to 0, well, it has to be a negative number, and it's going to be negative 5, which will add that up to 0. Once again, we factored it, we used the zero product property, and we solved for the x, which gave us our 0. Okay, here, tricky, tricky, tricky. Looking at the factors in 9, so that would be 1 and 9, 3 and 3, and I'm trying to make a minus 8. Oh, I remember this. Okay, so this came up in class. It turns out that there's actually a typo in this problem. You'll notice that the only way to make an 8 is if I made one of these negative, like if it were 9 minus 1. Whew, excuse me. Or if it were actually a positive 1 and a minus 9. Now you'll notice if it is a positive 1 and a minus 9, we will get the minus 8, but it's going to mess up our plus 9 right there, because when we multiply these, we'll actually get a negative. So let's just pretend like that was negative, and I did apologize for that in class when it happened. Let's see. So what that means is I would have x plus 1, x minus 9 equal to 0. The zero product property would tell me that x is equal to minus 1. The zero product property would again tell me that it's equal to 9. Now notice this time I didn't write out the equations like I did the previous 2 times. That's okay in the grand scheme of things. If it is something that you can do in your head, go ahead and do it, but if you are ever using the zero product property for something like this, say you had that inside of a parentheses, I wouldn't recommend it, but of course, you know, it's up to you. As you keep progressing in your math studies, you know, based off of the audience, there is an assumed level of proficiency that you've sort of matured your way into, and people will kind of take that for granted. So if it works for you, fine, but if you don't want to risk it on the test, just go ahead and show all the work. That's the best way to get partial credit. But here, this one, you'll notice something really strange is we don't have an equal to 0. It's actually a 4. Well, since that's a 4, we can't really use this zero product property that we talked about. So we had to think of a clever way to make this side of the equation 0. And I asked you guys to think about it. I waited, and eventually someone said, you know what, let's just take away 4 from both sides so that there is literally nothing there. If we take it away, it'll be gone and we'll have a 0 left over. And so what that does is it changes the problem slightly, but in a good way, because now we actually can factor this and it's equal to 0 so that we can use the zero product property. I like to call this math teacher magic because I engineered the problem to be that way. So let's see. 6 times 1, well, if I add those, it'll give me a 7. 2 plus 3, if I add those, it gives me a 5. So it turns out that's the combination that we would like. And now that it's in factored form, I can think about the zero property. X could be equal to a negative 2, or x could be equal to a negative 3. So again, notice that we're using the factoring technique that we learned from earlier. We're using the zero product property to help clean it up at the end and solve 2 little mini problems. I hope you found this video to be helpful, and stay tuned for the next one.